Introduction. Recent solar storms have been making waves in our space weather, coinciding with the autumnal equinox, a period when the sun's activity seems to kick into high gear. If you've been following our updates, you know that the sun has been exceptionally active, releasing some of its most powerful flares this season, including a massive X4.5 class flare from Sunspot region 3825. In today's video, we'll dive into these recent solar eruptions, explore how the equinox uniquely amplifies their impact, and discuss what these events reveal about our understanding of space weather. A sequence of solar eruptions and sunspot updates. The sequence of recent solar activity began on September 12, 2024, when an X1.3 class solar flare erupted from an unnumbered sunspot region near the sun's western limb. X-class flares are among the most powerful solar eruptions, capable of releasing massive amounts of energy that travel across the solar system. This particular flare was notable not only for its intensity but also for its impact, as it disrupted high-frequency radio communications across regions including Africa, Europe, and parts of Asia. Along with the flare, a coronal mass ejection (CME) was launched. This flare marked the beginning of a series of intense solar events. On September 14, Sunspot region 3825 took center stage by unleashing an even more powerful X4.5 class solar flare, which ranks among the top 5 largest flares of the current solar cycle. This eruption was paired with a fast-moving CME that, while not directly aimed at Earth, was expected to deliver a glancing blow around September 16. The impact from the CME on that date resulted in minor geomagnetic activity, briefly disturbing Earth's magnetosphere. This led to stunning auroral displays visible at higher latitudes, although there were no significant disruptions to satellites or communication systems. Adding to the sequence was an unexpected M-class flare from the same region on September 22. M-class flares, while less intense than X-class flares, still carry enough energy to disrupt communications and cause minor geomagnetic storms. This flare's eruption underscores how sunspots can rapidly evolve and destabilize, leading to sudden bursts of solar energy. Sunspot regions 3825, 3811, and 3814 have all been significant contributors to the recent solar outbursts. Region 3825 in particular has demonstrated the potential for further eruptions as it rotates into a more direct view of Earth, increasing the likelihood of direct impacts from future flares and CMEs, which are indicators of the sun's overall magnetic activity and are closely monitored as the sun moves toward its peak in the solar cycle. Geomagnetic storm watches and recent impacts. One significant event was the G3 geomagnetic storm observed on September 12, 2024, classified as a moderate to strong storm on NOAA's space weather scale. This storm was characterized by high solar wind speeds reaching up to 600 km per second and a southward-oriented interplanetary magnetic field, IMF. The southward orientation of the IMF allowed charged solar particles to penetrate Earth's magnetic shield more effectively, triggering geomagnetic disturbances. Geomagnetic storms are graded on a scale from G1 minor to G5 extreme, with each level indicating the potential severity of impacts on technology and infrastructure. The G3 storm observed in mid-September was significant enough to cause voltage fluctuations in power grids, especially in high-latitude areas where geomagnetic currents can induce power surges, disrupting electrical systems. In space, these storms can impact satellites by increasing atmospheric drag, affecting their positioning, and potentially shortening their operational lifespan. Another particularly severe storm, classified as G4, was observed on August 12, 2024, demonstrating the significant impacts of solar activity on our planet. During the August event, auroras were visible much farther south than usual, with sightings reported in regions that rarely experience such displays, illustrating the extended reach of these storms during heightened solar activity. NOAA's Space Weather Prediction Center, SWPC, plays a crucial role in managing the impacts of geomagnetic storms. It provides real-time data and issues storm watches to alert power grid operators, satellite managers, and other stakeholders. During the peak period of the sun's 11-year cycle, the frequency and intensity of solar storms are expected to increase, making robust monitoring and preparedness more vital than ever. The Equinox connection and why it matters now. The equinox plays a crucial role in amplifying the impact of solar activity on Earth, making it a particularly significant period for space weather. The autumnal equinox, which occurred on September 22, 2024, is one of the 2 times each year when Earth's equator aligns directly with the Sun. This alignment affects how Earth's magnetic field interacts with solar wind and charged particles, creating conditions that are more conducive to geomagnetic storms. This phenomenon, known as the Russell-McLaren effect, occurs during equinoxes when the magnetic fields of the Sun and Earth align in a way that makes it easier for solar wind particles to penetrate Earth's magnetosphere. This alignment not only increases the frequency of geomagnetic storms but also intensifies their impact, making equinox periods particularly vulnerable times for space weather. Historical data shows that geomagnetic storm activity nearly doubles during equinoxes compared to solstices, highlighting how these seasonal variations in space weather play a significant role in Earth's exposure to solar activity. During the recent equinox, this alignment contributed to increased solar wind speeds and the series of geomagnetic storms that we mentioned. The amplified conditions during the equinox create unique opportunities for observing natural phenomena, particularly auroras. These light displays, resulting from the interaction of solar particles with Earth's atmosphere, are often more vibrant and widespread during equinox periods, like the recent auroral sightings we mentioned. While auroras are the most visible effects of solar storms, the scientific significance of equinox-aligned activity extends far beyond these displays. These periods provide critical data that help researchers improve space weather predictions and understand the Sun-Earth connection. Studying how equinox alignments affect interactions between solar flares, CMEs, and Earth's magnetic field allows scientists to enhance forecasts and develop strategies to protect infrastructure from solar disruptions. The current equinox period also offers insights into the approaching solar maximum, helping researchers anticipate future solar activity and its impacts on Earth's environment. As the equinox amplifies solar activity, it underscores the importance of continued vigilance in space weather research and the need to prepare for the potential effects of solar storms on modern technology. #outro. Thank you for watching. If you enjoyed this video, please like, subscribe, and hit the notification bell to stay updated on all things space. Let us know your thoughts in the comments and we'll see you in the next one. Keep looking up.